So in this video we will study the determinant method. Actually the absolute value of the determinant we will use to find the area of the rectangle, area of the triangle. Okay, so if you have a triangle whose vertices are x1 y1, x2 y2 and x3 y3, then the area can be found by the half of the absolute value of the matrix. So these lines are straight lines are for the absolute values, and the inside straight lines are for the determinant. And this is the first point, this is the second point, and this is the third point. Okay, so the points are given. If you put all the points inside the matrix and take the absolute value and take the half of it, then it is the area of the triangle. Okay, so let's do an example. Find the area of the triangle with the vertices A, B and C. Here is the solution. So the area is the absolute value of the determinant. The determinant is for the first point 1, 2 here, second point 4, 5 here, and third point 6, 3 here. So first of all we will calculate the inside determinant. Okay, so just put 1 by 2 and the absolute value. Then inside determinant can be found by this by the expansion along the first row. So first I will write the first value, which is at first row and in the first column. So I will write negative 1 to the power 1 plus 1 times 1 times, deleting this and this, I will get this. So the determinant of this submatrix plus negative 1 to the power 1 plus 2, because this value is in the first row and the second column, times 2, this 2, times the determinant of the submatrix obtained by deleting this and deleting this. You can check, plus minus 1 to the power 1 plus 3, because this is 1 and this is 3. This is the value. So I will write 1 plus 3 times the determinant. So the determinant can be obtained by deleting this and deleting this. Now if we solve inside the thing, this is the absolute value. So I will not apply the absolute first. First I will solve everything inside. What is this? If I solve this inside thing, we get these values after simple calculations. If we do more calculations inside, we get this. Doing more calculations, a little more, and you get 1 by 2 times absolute value of negative 12. So what is meant by absolute value? Absolute value is the value which is always positive. So that means in the absolute sense there is no concept of the negative things. So if in the absolute value, inside the absolute, if you have negative thing, you have to ignore the sign of that value, because in the absolute sense there is no negative. So if there is no negative, I will write 1 by 2 times 12 without negative part. So then if I divide 12 by 2, I will get 6. So the area is 6 square units. Now we have a special case. In this case, if the area is 0, then the determinant must be 0. So this determinant is equal to 0 means the points x1, y1, x2, y2 and x3, y3 are all collinear. So that means when the points will be collinear, there will be no triangle. So when there is no triangle, so the area will be 0. So because the area of the line is always 0. Okay, there is another special case. If the one vertex of the triangle is at the origin, for example, the first vertex is A0, 0, then what would be the formula of the area? It is again one half of the absolute value of the determinant. In the determinant, the first point is 0 because it is the origin, and the second point and the third points are as it is. If we expand this determinant along the first row, because first row has two zeros, if we expand it along the first row, I will put the determinant outside, and then for the first row, this is 0, this is 0. I will not write these two values. I will write this value. Since this is in the first row and the third column, so I will write negative 1 to the power 1 plus 3 times 1 times the determinant obtained by deleting this column and this row, which is x2, y2, x3, y3. So if I solve if I solve this inside, I will get x2 y3 minus y2 x3 whole absolute times 1 half. So this is the formula for the area of the triangle whose one vertex is at the origin.